Today, let us have a discussion on a brief history of what is that DBMS applications. Got it? Historical development of database technology, we can say. Got it? So, just a minute. Somebody joined. Okay. Okay. Now, are you able to see the screen now?
Yes, sir.
Okay.
Sir.
Fine. Now, the historical view. If you go back to the history of the database management system applications, in early database applications, those were using hierarchical and network systems. Many early database applications maintained records in a large organizations such as a corporations, universities, hospitals, and banks. In early 1960s, we used to have a database applications. Those database applications were using hierarchical and network models. What it is? These type of data models were used in big organizations like universities, like hospitals, like corporations. Got it? So, in banks, the examples of university applications, similar informations would be kept for each student, each courses, each grade record, and so on. So, in those big organizations in early 90s or mid 90s, they used to have a databases. Those databases were used to have the technology called hierarchical and network models. Got it? And a bulk of worldwide databases processing still occurs using these models, particularly the hierarchical model using IBM's IMS systems. One of the main problem with these early database systems was the intermixing of conceptual relationship with the physical storage. Conceptual relationship with the physical storage. What is this conceptual and physical? Conceptual means, see here now, if I want to store the data, name of the student, university seat number of the student, and grade of the student, and date of birth of the student. See here now, name is what I thought conceptually I want to store it in the form of alphabets. It will be having some constraint. Every student will be having the name. So it is not having, it must, that column must have some value. Then it should not be null. Got it? That kind of conceptual thing and actually what we used to store in the physical storage. Both of them were used to mix it. And placement of records on a disk. See, whatever we stored in the disk and whatever we stored it in conceptuals and physical storage, all of them were used to get it mixed. Okay, there were no system like a relational data models. It will be in the form of paragraphs or it will be in the form of other things. Got it? So that was the problem in the early database applications. Then this is one among them. Then another drawback of that early system was that they provide only programming language interfaces See here now. Now, if I want to extract any of the information from the table, okay, what I will going to do? Select a star from this. Only what I want, I will going to write it on the query in the form of query. But in early database applications were not like that. If I want to access anything from the database, okay, hierarchical model or network models, I have to write the program for that. I need to write a program for that, and then only I'm able to access the information. Then only I am able to access the information. Otherwise, it is not possible. There were no queries. The queries are in the form of we need to write the program. When we need to write the program, it is expensive. Why it is expensive? Because this made it time consuming and expensive to implement a new queries, transactions, since new programs has to be written, tested and debugged. Most of these database systems were implemented on large expensive mainframe computers starting in the mid 60s. If we want to implement any of this, so we need to implement with a large mainframe computers. Got it? So these are the two disadvantages. Which are those? One is interface if you want to extract or if you want to store any of the information, or if you want to modify the information, you need to write the program. If you need to write the program, it is a time consuming as well as it is expensive. Why it is expensive? Because we need to write the program, we need to test it, and we need to debug it. Got it? This is. And another one was, what is that? The main problem with that database was intermixing of conceptual relationship with the physical storage and the placement of records on the disk. Okay, these things will get mixed and store it in the disks. These are the two disadvantages or the disadvantages of this. Okay, because of these, most of these databases were implemented, as I told, in the large expensive mainframe computers. Nowadays, if you are having a database, if you want to store or if you want to maintain your own database standalone, then you can get it, you can do it in your desktop or laptops. Got it? The main types of early systems were based on three main paradigms: hierarchical systems, network model based systems, and inverted file systems. There are three types of, in the early 60s, okay, there are three types of database models. Okay, one is hierarchical system model, second one is network model system, and inverted file systems. With these things, they used to keep their datas. Now, next is, because of keeping these things in mind, okay, so providing a data abstraction and application flexibility with a relational databases. Which one? Relational model based system. Relational model based system, they come up with data abstraction and application flexibility with the relational databases. See here now, what is this data abstraction and application flexibility? Data abstraction means, as I told, okay, first you must have this, okay, the name of the student and name and data type, etc. Okay, the constraint, etc. This is called as a data abstraction. Okay, only by looking at the table structure, you will come to know what kind of values are stored. You are not seeing the data You are not seeing the value within that table. Just by looking at the structure of that table, you will come to know, okay, what kind of values you are storing, what you want to store, okay, whether extraction is possible or not, means that particular head is there or not. Got it? So it is. The relational databases were originally proposed to separate the physical storage of data from its conceptual representation, and to provide mathematical foundations for data representation and querying. What we used to do, separate the physical storage. Physical storage is different, and the conceptual representation, both of them are segregated, because it is the one of the problem in the early 1960s databases. Okay, in hierarchical and network models, it was the one of the disadvantage. That was the problem they used to have. Okay, now that problem is solved by segregating a physical storage of data from its conceptual representation, and it's provide a mathematical foundation for data representation and querying. See here now, in third unit we'll come to know how exactly aggregations and all those things are used to extract the information. Okay, to extract the information, to retrieve the information. Okay, the mathematical models are used for querying purpose. The relational model data models also introduced high level query language. See here now what I want, only that can be accessed. In the early hierarchical models, if I want to extract any information or if I want to store any information, I need to write the complete program. Now it is not like that. If I want the information of any employee, okay, select star from employee, so I'll get all the employee details. If I want only name of an employee, select name from employee, so I'll get the name of the employees. Got it? Which you want, that much specific you can get it in the relational model systems. See, this is what the beauty of the relational model system. This is the advantage when you compare to early database applications. Early experimental relational systems developed in 1970s. These relational model based systems were introduced in 1970s, and the commercial relational database management means first in 1970 they have tested, and after that commercial relational database management system, RDBMS what you can call, introduced in the early 1980s. In 1970s they have tested, they have gone through that, okay, and experimental relational database management system they introduced in the 1970s for the practical purpose. In later 1980s we got a software relational database management system, RDBMS, as a commercial product. Now, since they did not use a physical storage pointers or records placement to access related data records, with the development of new storage and indexing techniques and better query processing and optimization, the performance improved. These are all the things they have implemented in this. Because of that, performance is improved in the RDBMS. Eventually, relational databases become the dominant type of database system. Gradually, this RDBMS become a dominant type of database system for traditional database applications. Relational databases now exist on almost all type of computers. Now we are all using this RDBMS relational database management system for our this thing. Whenever you go for doing the projects, you are also using this RDBMS system. RDBMS system on almost all types of computers, from small personal computer to large servers. In the most large servers are also using the same RDBMS systems. This is what the relational database models. In the early 1960s, we used to have, in early 1960s, we used to have, just a minute, let me open the pen. In early 1960s, we used to have database models in the form of hierarchical and network models. These were introduced in mid 1960s. Okay, what are the disadvantages of these applications? They used to mix the physical as well as conceptual things. And if you want to extract any of the information, or if you want to store the information, or if you want to do any of the processing with those databases, then you need to write the program for those. Okay, if you want to store a small value, so you need to write a program. If you want to extract a value, then you need to write a program for that. And if you want to change any of the value, for that also you need to write the program. Okay, so writing the program is time consuming and expensive, because you need to write the program, you need to test it, and you need to debug it. So it is time consuming as well as expensive. Okay, this next is, because of these things, we have relational database model, RDBMS. Okay, here the data are stored in the form of, what is that, tables. Relation means tables. Okay, these data are stored in the form of tables. This practical purpose, the RDBMS concept was introduced in 1970s. Okay, and later as a commercial product, it was brought to the market in the mid of the 1980s, or early 1980s, as a product, commercial product. Got it? There are like what do you call it as indexing techniques, better querying processing, and optimization. So these are all the things. They improved the performance of an RDBMS. Now, from small computer to larger servers, we are using RDBMS concept still. Okay, this is all about relational model database systems. Now, after that, we are having next concept, object oriented and emerging applications. After the relational database models, we have object oriented applications and the need for more complex databases. Because of this object oriented concepts, we need a more complex database management system. Okay, this is called as object oriented database management system, in short OODBMS. OODBMS were introduced in the late 1980s, which is introduced in late 1980s. In the early 1980s, the RDBMS product came into the market as a commercial product. In late 1980s, we have the concept called OODBMS, Object Oriented Database Management System, and early 1990s to cater the need of complex data processing in CAD and other applications. Now, The emergence of object oriented programming language in the 1980s and the need to the store and share the complex structured objects led to the development of object oriented databases, that is called as OODBs. Initially, these object oriented databases were considered a competitor to the relational databases. These initially in 1980s, these OODBs, object oriented databases, were treated as a competitor for this relational database management systems, RDBMS, which is in the market as a commercial product. Then competitor to the relational databases, since they provided more general data structures, because these are having more general, because it is a object oriented generalized data structures. They also incorporated many of the useful object oriented paradigms such as abstract data types, encapsulation of operations, inheritance, and object identity. These are all the things you have studied, okay, or you will going to study it in the Java, okay, in Java technology. What are those? They have inculcated, they have introduced, okay, or as a part of that object OODBs, object oriented database management systems, they have introduced or inculcated the encapsulation, data abstraction, and what is that one more, the inheritance concepts and object identity. These things were made a part of that OODBs. Hence, because of these all the features, okay, in early 1980s it was treated as a one of the competitor for relational database management system, RDBMS. Got it. However, the complexity of the model and lack of an early standard contributed to their limitations. Limited use. They are now mainly used in specialized applications. These OODBs are mainly used in specialized applications. It is not used commonly as we are using RDBMS. As we are using RDBMS, even we do a small project, okay, what do? We use this RDBMS, not OODBs. Got it? So they are now mainly used in specialized applications such as engineering, design, multimedia publishing, and manufacturing systems. Only in these areas these OODBs are used. Despite expectations that they will make a big impact, their overall penetration into the database products market remains slow. Because of these things, the what are those impact, what it, their overall what do you call it as penetration into the databases is low in the market. Many object oriented concepts were incorporated into the newer versions of the relational databases. These object oriented OODBs, object oriented database management systems, were become stagnant, but the relational database management systems were updated. They come up with the newer versions of the relational database management systems, leading to object relational database management systems known as object oriented relational database management. They come up with the Think object oriented relational database management system. See here now, these OODBs were become stagnant, but those relational database management RDBMS, they have updated themselves and they come up with the concept new version called object oriented relational database management system, ORDBMS. They come up with the ORDBMS. Because of this, okay, this RDBMS is used more commonly, okay, more frequently in everywhere, but OODBs are used in with very specific, okay, areas like a multimedia publishing, manufacturing systems, and some engineering designs. Only there these things were used. Hope this object oriented and what is that data in where object oriented and emerging applications with the help of object oriented database management systems is understood. Okay, now next is the next concept after the object oriented database management system, OODBs or OODBMS. We have one more concept, which is interchanging data on the web. After that, after the object oriented technology, we have more frequently in touch with the web, interchanging of data on the web. Now we are sending the money from one place to another place, one account to another account, okay, through web. E-commerce, nowadays you see all the things, shoppings and all, nowadays it has become online. Got it? So data on the web and e-commerce applications were the next latest technology. Got it? The World Wide Web, just a minute. The World Wide Web provides a large network interconnected computers. The web is largely connected computers, interconnected computers. Users can create static web pages using the web publishing language such as hypertext markup language. Okay, they using HTML they have created what is that, web publishing this, and store the data documents on the web server where other users can access them and view them through a web browsers. Nowadays, see here now, all of you are having the Facebook. Okay, you can have your own website also. You can have your own website also using the HTML code. You can write, you can create your own database, websites. With the help of those websites, you can upload all your documents, your resume, your photos, and your certificates, etc. All the things which you want. Okay, all those things, and other users means client can see all those things. If you go with our college website, okay, we have provided all the informations. Okay, we have included all the information in our college website. Okay, all the students can access it, all the staff members can access it, and other than a student and a staff members, others can also see our information through this web. Got it? We have stored all our information somewhere in the server. We have created the program or website with the help of HTML. Got it? So this is how the things are stored and published with the help of others, with the help of web browsers. Documents can be linked through hyperlinks. Documents can be linked through hyperlinks, which are pointers to other documents, starting in the 1990s. See here now, it has started since from 1990s. Okay, how if you want to, or if you are having the documents, you can link it through the hyperlink. Got it? Which are pointers to the document. So these hyperlinks treated as a pointers to the document in the starting 1990s. Electronic commerce means e-commerce emerged as a major application on the web. Nowadays, see, more of the things we do shopping with the help of what is that? E-commerce. Amazon, Flipkart, Snapdeals, okay, First Cry, etc., etc. This much of the electrical information on e-commerce web pages is dynamically extended from DBMS, such as flights information, product prices, product availability. If you want to purchase any of the product, what you will going to do? You will compare in this. You will be having that product is available with the comparisons. Then you can decide on yourself and which website we need to go for purchasing it. Got it? So you can have flexibility to compare. Okay, and you will purchase through websites, these e-commercial sites. Then you can go for availability of the flights. Where you will going to check? With the help of web. Got it? And prices you will going to check. Okay, seat availability. All the things can be done through the web. A variety of techniques were developed. To allow the interchange of dynamically extracted data on the web for display on the web pages. Extended markup language. Next, we have after that HTML. We are having the XML. XML is extended markup language. Extended markup language is one standard for interchanging data among the various types of databases and web pages. XML combines the concept from the models used in documents system with the database modeling concepts. Okay, we are going to discuss not only we're not going to discuss about these things. You can study more in detail in web technology. Okay, better we spend more time on or throw more light on this XML in web technology, this thing. After that, we have now the last, extending database capabilities for new applications. See here now, we are having n number of new applications are there. Which are those? Which are those n number of new applications? There, these extending database capabilities for new applications, such as database systems in traditional application, increased level operators of other types of applications attempt to use them. Such application traditionally used their own specialized software and file and data structures. Database systems now offer extensions to the better support specialized query requirements for some of the applications like a scientific applications, storage and retrieval of images including scanned newses, personal photographs, satellite photographic images, and many more. So these are the things. This is, we have extended our applications for this, not only for the data. Earlier we used to have a datas. Okay, we used to store the data of student name, student, etc., etc., like it will be in the form of values. Now the same thing is extended for this database. Applications were extended for images, videos, audios. Images includes your personal videos, images, satellite graphics, okay, photographs, etc. Images from the medical products such as the x-rays, MRIs, etc. Using these things also. Got it? The applications were extended for this, and the same application database applications were extended for data mining, time series, etc. What is this time series? Time series means applications that store the information such as economic data at the regular point. Okay, economic data at the regular point means, if you can see the what do you call it as in Mumbai Bulls, what do you call it as market, share market. Okay, so from last 10 years from this day, 10 years before, 10 years on the same date, okay, 19th of May in 2000, okay, what was the, at this point of time, what was the economy, okay, what was the status of the share market, okay, you will come to know. So because it will be having from periodically, time to time, it will be storing all the information. Got it? Best example I will tell you, such as the daily sales and monthly gross national products figures. If you go for any of the e-commerce, they will be having at this point of time, 2 years before, what was the sales on a particular product or a particular branch. Got it? See, this is what. Now, it was quickly apparent that basic relational systems were not very suitable for many of these applications. Usually one or more of the following reasons. See here now, we cannot get all those things in RDBMS. It is not possible. Okay, why? Because more complex data structures. Nowadays we are having the data in the form of videos, data in the form of audios, data in the form of pictures, okay, time series, etc., etc. Because these things will be having a complex data structures. Complex data structures. Got it? See, nowadays you can search by just you enter your name on the Google. Okay, what happens? You can get similar kind of things on the screen. Thousands of related information will be displayed on the screen. Just by upload your photos, it is not possible because it is complicated. It is not so easy. Okay, so because it involves a lot of computations, lot of manipulations. Got it? Now, because of this complex data structure, new data types were needed in addition to the basic numeric and characteristics. As I told, see here now, if you store just a name, you need, for storing purpose, what you need? You need character type, where char. If you want to store a mobile number, integer type. So only numeric and character values were used to store. But nowadays we're having a complex new data types were needed if you want to store the videos, if you want to store the audios, etc. For this purpose, the what do you need? You need a more number of data types. New operations and query language constructs were necessary to manipulate the new data type. New operations and new query language is required. New kind of operations are required to retrieve and store all kind of things. New storage and indexing structures were needed. Okay, for storage purpose also we need a different kind of things other than the relational database management system, RDBMS, which supports RDBMS. Because of these things, RDBMS, okay, have limitations. Then this led to the DBMS developed to add a functionality to their system. Some functionalities was general purpose, such as incorporating concepts from object-oriented databases into relational systems. Means the object-oriented concepts were kept in the form of relational databases. Now we are having in the era, okay, now we are having in the era called NoSQL. NoSQL, emergence of big data storage schemes, systems. Okay, we need a large database system, big database systems for storing a huge amount of information, datas like a warehouses, etc. Why do we need? Because we are storing all the things. See here now we are unable to transfer a video which you captured through your mobile. It is not possible because the file is larger. Got it? So why? See, all these WhatsApp people, they are having their own server, in their database. Whatever we do the transfer of information, messages or videos or any media, okay, that will be stored in their databases. See here now, just imagine that you have not deleted any of your messages from last 1 month. Your phone will become hang. It start hanging. But those, how many of them are using WhatsApp? All the transactions will be kept stored in their databases. Clear? So that much of big storage system is required. And NoSQL databases. NoSQL databases means it is not only SQL. NoSQL means it is the latest technology, it is the latest thing in the database concepts now. Okay, it is the latest thing in the database concepts, database application. What is that? Warehouses. As for storing purpose, for retrieving purpose, we need NoSQL databases. NoSQL means not only SQL. SQL means structured query language. SQL means structured query language, which is supported by RDBMS. Now, for a warehouse kind of thing, you required such a thing for extracting or storing whatever. That is required NoSQL databases. That requires NoSQL. NoSQL means not only structured query language, not only SQL. Got it? In the first decade of the 21st century, the proliferation of applications and platforms such as social media websites like your Facebook, Twitter, Instagram, okay, large e-commerce companies like Amazon, Flipkart, Snapdeal, etc. Web search indexes and cloud storage backup led to surge in the amount of data stored and large databases and massive servers. Because of these things, which website, social media websites, see here now, earlier when there were no mobiles and all those things, whenever it is necessary, we used to go for the photo studio to get our images, hard copy of the images. Okay, whenever the special occasion is there in the home, okay, then we used to have the photographer, and later only few photos were used to get it, hard copies of the photographs. Now, when this selfie concept came into the market, got it? See, for each and everything, how many photos will be there? You will be having for this and that, okay, for this side, that side, etc., etc. For each and every moment, we used to take the photos. We used to take photos and videos. Immediately, we used to upload it to the social medias, Instagram, Facebook, WhatsApp, etc. Got it? So, because of these things, and our e-commercial companies, commerce companies, like what are those? Such as Flipkarts, Amazon, okay, yeah, First Cry, etc., etc. There are so many things. Okay, because of all these things, we must have larger servers, because images, videos will be having the larger sizes. Each of the file will be having more size, but whereas a text will be having less. Got it? So whenever your memory is full, what you will going to do? You will going to delete or clear your memory for wherever the photos are there, videos are there. You first delete the videos which consumes more size, then you go for images, then other things. Got it? So some of the requirements of these new systems were not compatible with the SQL relational DBMS, that is RDBMS. Got it? So the term NoSQL is generally interpreted as not only SQL. It is treated as not only SQL, meaning that in a system that manage the large amounts of data, some of the data is stored using SQL systems, whereas other data would be stored using NoSQL depending on the application requirements. Some of the things will be stored using SQL queries, structured query languages, and whereas other data would be stored which is not having a thing called a structured SQL queries will not going to support. For that kind of thing, we use NoSQL, not only SQL, depending on the application requirements. Based on the application requirements, we'll be using those things. This is what about the brief history of the database management system. This is the brief history of database management system. Hope it is clear.
Yes, sir.
Is there any doubts? Okay, it has started
No,
from
sir.
1960s. Okay, in the 1960s, the first database applications were introduced. In that database applications, there were no if you want to retrieve and etc., what you need to do, we need to have write a program, separate program, and debug it and do that. It is a time consuming. Because of that, we have a next relational database model, relational database management system, RDBMS concept. In that RDBMS concepts, we have tables. The information is stored in the form of tables. Got it? It was separated conceptual part and physical storage part. Okay, this is it was in the 1970s. It was in the 1970s. Later, in 1970s, the practical purpose RDBMS was introduced, and later 1980s, early 1980s, we have a commercial product of that. Okay, so after this, we have an object-oriented database management system. Okay, after 1980s, we have an object-oriented database management system. There, more about the specific thing, which is having the concepts called inheritance. Okay, then what is that? Indexing, other things. Okay, because of this thing, complicated thing, and other features, this was a more specific, and it was used only for the limited areas. It was used in the limited areas. Okay, then in the early 1980s, that commercial product of the RDBMS, okay, they were updated their product RDBMS as an object oriented relational database management system. Then these were stagnant. OODB was stagnant, and their RDBMS came into released a new version called object oriented, that relational database management system. So that was upgraded, and still today we are using that RDBMS. Got it? From small project to a larger product, larger servers, where still we are using those things. Got it? Later that we have one more called what do you call it as after that we have which one? Extended database capabilities. So there were new applications where came into the market. Okay, to overcome those things, these things were not able to store some of the things in the databases. Okay, because of the new concepts and a new thing. Okay, later after this we have the things called a web technologies. So web technologies in the form of what do you call it as datas are stored and accessed with the help of webs. Because of this web concept, okay, we have commercial products, sorry, not commercial products, so we have called websites, okay, social media, and we have a commercial e-commerce. Okay, because of this large amount of database data were stored in the servers. Okay, all our images, that kind of thing. Okay, because of these things, so SQL is not supporting, or that RDBMS was not supporting storing of videos, etc., which was having only the data types for characters as well as the numbers, but there were no data types for the images, videos, audios, and other things. Okay, because of this concept, because of this drawback, we are having a concept called NoSQL concept. In this NoSQL concept, SQL means not only SQL, not only structured query language. Okay, because of these things, we are able to do all the storing of videos wherever the character and integers are there, number systems are there. There we use the SQL data types, and for other things we use NoSQL concepts. This is what the brief history of the database management system. Hope you understood. Is there any doubt?
No, sir. No doubts.
No.